Breaking the Wall of Biomarker Sensing. Christian Heck, Universität Potsdam, BAM, Humboldt-Universität zu Berlin, Germany.
Biomarkers are molecules which tell us whether a person either has a certain disease or is likely to get it in the near future. So for an early diagnosis, the detection of these molecules, for example in a drop of blood, is essential. And this is the wall I want to break. Now there's a number of different such biomarkers, and they can be indicative of all kinds of different diseases. At the same time, they're present only at low concentrations. So we need a powerful analytical technique in order to be able to detect them. The technique we want to use is called surface-enhanced Raman scattering. It has a tremendous sensitivity, can detect even single molecules. At the same time, it gives us a very detailed spectrum, which is like a fingerprint for each molecule and helps us to tell them apart. Now, the technique comes with one big drawback. The very intense signals, they're generated from tiny metal nanoparticles, from gold or silver. And only if these particles are arranged exactly in the right way together with the analyte, we get these huge enhancements. Now, in order to solve this nanoscale arrangement problem, we use something called DNA origami, where DNA is used as a building material. And it can be folded into more or less arbitrary shapes. You can build these triangles or these tuning forks. And most importantly, you can also attach metal nanoparticles to them, the particles which will enhance the Raman signal for us. Now, the structures I work with in the studies of my PhD have 3 differently sized particles. And if we zoom in, we can see that also the analyte molecule is bound in between the particles. We can bind just a single molecule if you want. And this is exactly the spot where the highest enhancement is found. Now, this is a nice 3D schematic, but to show you that it actually works, we have an atomic force microscopy image here, which shows you the triangular DNA scaffold with 3 differently sized particles. And so far, we measured model analytes, for this spectrum here, a dimolecule or single protein streptavidin. But in the future, we hope to extend this to real biomarkers, and then we'll be able to detect the diseases before everyone else can. Thank you.